Hey guys, welcome back. I hope you had a good weekend. We're moving on with section 8 to day 2 here. Last week we looked at law of sines. Now we're going to look at more with that ambiguous case we talked about last week. So a few reminders here. When we talk about a triangle that is ambiguous, that only happens when we're given this, right? And if you spell it the other way, it has a bad word in it. That is the only time we have to worry about this ambiguous situation. When we use law of sines and we're given SSA. All the ambiguous case means is that there's three possibilities, and when we start the problem, we don't know exactly which of these three possibilities are going to occur. One possibility is that we don't get any triangles at all, and I'll show you a visual here about how that could happen in a second. Maybe only one triangle works. Now today we'll see when only one works, and there's a key here that occurs when the angles of the second triangle can't add to 180 degrees. And the third option is two triangles can be formed. All ambiguous means is that when you're given SSA, one of these three options are going to occur. Ambiguous kind of means you're unsure when you start it. By the end of the problem's not ambiguous anymore. You're going to know exactly which of these three situations occur. So let me show you a few reasons for why especially this third option, two triangles can be formed. I have a few visuals here that help us see that. So there's a trig reason for these two triangles. A lot of times when we use law of sines, we're solving for an angle, okay? So let's say we set it up and you do something like this, right? B equals sine inverse, and you have some big ugly thing there you found in law of sines. When you do that, that's always going to be a positive. And back in chapter 7, when we solved these triangles, you guys knew that if you had a positive sine ratio in quadrant 1, that means you also have an angle that has a positive sine ratio in quadrant 2. So I'll just try and get rid of that line there. All right. So when you do sine inverse of whatever that ratio is, you get an angle, right? So let's just say that B, B is approximately some angle. The other angle in quadrant 2 would be 180 degrees minus B, right? Whatever you got. So that's why there are two possible triangles. When you use law of sines and you sine inverse both sides, you might use the red B, or you might use that blue angle, which is another option to make another triangle. All right, so that's why this ambiguous case happens. This is another little visual shows what's going on. So if we were in class, what we would do is we'd make these different colored little segments, and you would kind of play around with these triangles. What I'm giving you here is actually an angle, right? There's the 30-degree angle. I'm giving you this 6-inch side, and then one of these other colored sides is your other side. So I'm giving you angle, side, side, right? Makes the bad word, angle, side, side. And what you would have seen here is if you messed around with a few of these sides, like look at the orange one, that's 2 inches, all right? So if you would have messed around with this in class, you would have taken that 2-inch segment and you would have attached it right here, right? That's 2 inches. So you can see I'm given angle 30 degrees, side of 6 inches, and a side of 2 inches. That's an ASS. So if you look at this picture now, there's no way I can make a triangle, right? That 2-inch segment right here is not long enough to get down to this side down there. I can't change either of the two sides of the angle. So again, the only other way to deal with ambiguous triangles is to actually measure the pieces and measure the angle and actually try to construct the triangle each time. That's not worth our time. It's easier to go ahead, try law of sines, solve for some angles, and know that this ambiguous case might happen. All right, let me show you another situation here. So if you messed around with another angle or another side, right? So 30 degrees is the angles, the 60 inches is the side. Let's say we used a longer one. I think if we use 6 inches as the side down here, this would have happened. So, actually not the 6-inch, sorry. Let's do that. If it was with a 4-inch, this would happen. So if you took a 4-inch side and you were messing around in the class, you'd be able to make one triangle right there with a 4-inch side. You guys can see the triangle, 30 degrees, 6 inches, and 4 inches. And the reason there's a second triangle is if I take this 4-inch side and I kind of swing it that way, right? So I'm going to kind of bring it over to this other side. Keeping the angled 30 degrees, the side 6 and the side 4 the same, what you'll see is this. Boom. 4 inches. What I've just made is another obtuse triangle in here with the same 4-inch side. So you can see, given one angle, 30 degrees, and the 6-inch side and the 4-inch side, I was able to make two triangles. The big one that's kind of in blue, and then the obtuse one that's in red. Okay? So there's a visual of 0 triangles happening and of 2 triangles happening. 1 triangle happening is just when only one situation works out. So we'll take a look now. Again, the only other way to handle these ambiguous triangles is if we actually went through and constructed them like this every single time. That's not worth our time to actually measure the little segments and mess around with that. So that's why we do this algebraically. Okay, so take a second. If you're using the notes that I posted on Schoology, this should be the next example. I forgot to tell you that there are blank notes posted on Schoology if you want to use those. So let's just see how this works. First of all, you should be able to tell right from the beginning that I'm giving you an angle and a side and a side. Remember, it's got to go in that order. Angle, then a side, and then a side. Right? Not just 2 sides, but in the angle, in that order, angle, side, side. Okay. So, yes, that's ambiguous. All that means is we don't know what's going to happen. There might be 0 triangles here, which we saw last week. We typed in a calculator and got an error. That means 0 triangles are possible. There might be 1 or there might be 2. So let's try setting this up. I kind of color code this. Let's be in red for this first one. So if I look here, I got sine of 25 degrees over 1. Remember that 1 is across from 25, so the 1 and sine of 25 go together. And the first angle I can find here is A. So I'll do sine of A over 2. Okay? So this is the same thing we did last week. We cross multiply here a little bit. We get 2 sine of 25 degrees. And you're going to the calcs. Sine inverse both sides. You get sine inverse of 2 sine of 25 degrees. And if you go to the calc, type that in, you should see 57.70 degrees. The online homework, of course, will tell you what to round to. Okay, so there's the 57.70 degrees. That is one possibility for A, okay? Now this is where you have to pause. What we just did, think back to that what I showed you on this slide. You just found that red triangle in quadrant 1. Now you've got to ask yourself, is there a second triangle possible? If angle A is 57.7 degrees in quadrant 1, then the other angle A. Now see what I've done here? This is the exact same triangle to start, the 25 degrees, the 2 and the 1, right? So here's the first triangle, 25 degrees, 2 and 1. Here's the second. All I did was I used the same letters, but I put those that little apostrophe up there. We call that prime, A prime, B prime. And all that does is that signifies a second triangle now. So if the first angle A in red here was 57.70 degrees, the other option for A, oh, sorry, I'm going to color code this. The other option for A is 180 degrees minus 57.70 degrees. That's that quadrant 2 angle. So 122.30 degrees. There's that obtuse triangle we saw when I kind of messed around with those segments there. Now, again, I know that angle A prime is not 122 degrees. Don't worry about drawing these to scale, right? We're not taking a lot of time to do the construction of these actual triangles. So there's my second option. Now, after you do that, what you're doing, you just basically have 2 problems in one. You've got to mess around with this red triangle, find all the missing stuff, mess around with this blue triangle and find all the missing stuff. And that's it. Once you find that first angle and you use it to find the second angle in the second triangle, that's the only time the 2 triangles interact, okay? After that, you just mess around with everything in red. So angle A we have 57.70 degrees. Now that we have 2 angles in the triangle, we can find the third. 180 minus the first 2 we have leaves us with 97.3 degrees as the third angle. And now for side B, you've got to go and set up another law of sines. So I'm going to do sine 25 over 1 equals sine of, now because I have both angles there, whatever, I could have used 57.7 and 2, but I talked about last week I want to be exact, so I'm going to use the sine of 25 and 1, and now I'm going to use the sine of 97.3 over side B, okay? Cross multiply, clean this up just like we did last week, and you should be able to get 2.35 as lowercase b, which is side B in this first triangle. And that's it. The first triangle solved. But now we got to do the Second triangle. So if C prime was 25, A prime was 122.3. Same process from the first triangle. We do 180 minus those two angles we know, and we get 32.7 degrees. Okay? And to find side B prime, it's another law of sines. Sine of 32.7 degrees over B prime equals sine of 25 degrees over 1. Cross multiply and clean this up. You should get a B prime value of 1.28. And there's your second triangle. I can't do a dual page on this, but what you're seeing here is triangle one option, right? A, angle B, side B. That makes a triangle. And so does this. So two triangles. That was only possible because we were originally given an angle side-side combination. All right. That's it. Let's take a look at another one. So, would there be a second triangle if you saw this? So we're going to save some time here really quickly just to show you what it looks like when only one triangle works. So, again, look what you're given. Angle, side, side, right? So this is ambiguous. Okay? If you set up your law of sines like I did here, and you solve for that first angle, you get an angle of 25.37 for C. All right? Same thing we just did in the last example. We're just not going to do another example like that. After you find the 25.37, your very next step has to be come over here and find C prime. So that's, again, this one down here is in quadrant 1. What you're basically doing is finding the angle in quadrant 2 that also has the same sine ratio. So we do 180 degrees minus 25.37 degrees. And your C prime then would be approximately, I just realized I'm in green. I wanted to be in red. No big deal. Should be approximately 154.63 degrees. All right. So, what do you see? Look at the second triangle, the one with primes on them. I just said that C prime was 154 degrees. That's the only other option coming from the 25.37. That's not wrong. My problem is this. Look at what A prime is. Those two angles already add up to more than 180 degrees. It is impossible to have B prime. That means this triangle does not exist. It's impossible, right? This one's out. So that is a case of only one triangle working. All right. Again, the only reason, these are called ambiguous because when the problem starts, we don't know what's going to happen. We don't know if there's going to be 0 triangles or 1 triangles or 2, or 1 triangle or 2. By the end of the problem, it's not ambiguous anymore. You know what's happened. There's either 1 that worked, 2 like the last one, or 0 if you see an error in your calculator like we saw last week. Okay, so that's pretty much it. Ambiguous at the start, not ambiguous when we're all said and done. So there's another example here. If we were in class, we would take a few minutes with your teammates to work on this. I'm going to let you guys try this on your own. Right, the answers are right here on this slide, so you can check them out. Again, it's very similar to the very first example we did. Here's the start. These are in your notes, but the answers are not. So there are the answers if you want to jot them down really quickly and make sure you can work through this example. This is a really good example of the skill we're working on today. Again, you can see you're given an angle side-side. So yes, this is ambiguous before you even start. That's why two triangles are possible. I just realized this wasn't zoomed out enough. Sorry. There's the third side for the blue triangle. Okay, so write those problems down, those answers down, and give it a shot. And that's it for today. I lied. I'm sorry. I wanted to show you one application of these, and then that's it. Okay, so the reason I want to show this is because a lot of times our word problems go from that horizon view, I call it, where it's kind of like you're playing not Game of Thrones, kind of like you're playing Angry Birds, right? Where you have the little slingshot here and you shoot it, and it goes like that. We did rocket examples like that. We've done a ton of stuff. Okay. Sometimes, though, the problem is from an aerial view, kind of like you're looking down at a map. And that's what this one's saying. Okay. So take a second and read the problem. Two meteorologists are 25 miles apart, located on an east-west road. The meteorologist at point A cites a tornado northeast 38 degrees. The meteorologist at point B cites the same tornado at northwest 53 degrees. Find the distance from point A to the tornado. Okay, so sometimes we have a little bearing in here, right? That's what these angles are with degrees and direction. So it's kind of combining bearing with our law of sine. So take a second, pause the video, and see if you can't set up this picture. Okay, so here's what's going on. We have A and B on an east-west line, right? So basically they're perfectly horizontal from each other. We have the tornado somewhere in between them. Now it's not direct, it doesn't say that it's directly in between them. So we can't assume that's the case. All right, so what we'll do is we'll draw a little twister over here, right? There's my tornado. And we know, like I said, A and B are a perfect north-south line. I'm sorry, east-west line. So they're horizontal left to right. All right. And the next problem says this. Again, from an aerial view. That person A sights the tornado at northeast 38 degrees. Okay, so remember, bearing is always from this north-south line. North. Now, if you're wondering why I put A kind of on the left side, it's because I knew A's bearing. Northeast, here's the tornado, northeast is in this direction, right? North and then east is to the right. So I knew that A had to be on the left. B is looking at a northwest in a northwest direction. That means they had to be on the right. Okay, now be careful. Remember we talked about last week. Bearing is not this angle there. That's a reference angle. Those are the angles we use in a lot of trig. But bearing is the one time that we're allowed to go from the vertical line, the north-south line, and we know that that is 38 degrees. So a little trick there is using the bearing. Bearing is always an angle. It's not a distance. It's an angle. So that's the setup for the left side of the triangle. B now looks at the triangle that way, or looks at the tornado there from the north-south line, right there. B's bearing is 53 degrees. Again, that angle there, not the angle in the triangle. Okay. So that's a setup. We know that they're 25 miles apart. And I want to find the distance from point A to the tornado. So I want to find this distance right there. Okay, so I think it's obvious we want to deal in this triangle right there, right? Once we get the picture set up, these problems you're either going to use sines, cosines, and tangents, and Pythagorean theorem. You can only use those two if it's a right angle. I don't see any right angles here, so that's out. And right now your only other option is law of sines. So how can I get angles in that blue triangle there? Well, because A and B are on a perfect east-west line, if this top angle by A is 38, I know that this angle here in blue has to be complementary. That means it adds up to 90. So if the top angle is 38 degrees, I know this has to be 52 degrees. Same thing on the right side here with angle B. If the top angle there is 53 degrees, I know that this has to be 37 degrees. The only reason I know that is because it says A and B are on an east-west road, and the angles in red were given in bearing. That's what allows me to set up that picture. All right. Now that I know these two angles here, you should be able to set it up. I can pull up a calculator. So let's try to set this up and finish this together so you can see this answer before you leave. Okay. So because I'm looking for x, I'm going to use sine of 37 over x, right? And then the only other fraction I know, or the only other side I know is 25 miles. In order to use 25 miles, I have to find the angle across from it, right? So let me see, the two angles we have 52 degrees is one, and 37 is the other. So if you subtract that from 180, we know this angle up here is 91 degrees. So I can do sine of 91 over 25. And once you set that up, you're doing the same thing we've been doing. You can cross multiply and solve for x. Here's what you should see. 25 sine of 37 degrees. I've been putting the degree marks on these angles because it just reminds me that I'm in degree mode. And then I'm going to divide that by 25. Okay? So check your mode. Again, like I said, we should be in degree mode for pretty much every problem. My calculator's in radian, so let me fix that. Just to make sure you can type this in and get the right answer, we should have 25 sine of 37, and then divide that by 25. All right, so your answer should be 0. I would tell you what to round to, but 0.602 is what I'm seeing on the calc, miles. That's how far the tornado is from person A. That's this side right there. Okay, so that's a good example of the setup, and then using law of sines to execute and solve the problem. Remember, only sine, cosine, and tangent, the SOHCAHTOA stuff and Pythagorean theorem if you're given a right angle. This problem didn't have a right angle, so I have to use law of sines. Okay, guys, your homework is 8.2 day 2 online. Remember, we will have an office hour today. Every day that math is on, every Bronco day, our office hour will be from noon to 1. So stop in, ask a question, just say hi, and I hope everything's going well. Talk to you guys soon. Bye.